The first type of improper integral is having an infinite interval. What is an infinite interval? Look at the two graphs I prepare for you. On the first graph on the left, we have x goes from a all the way to positive infinity. The graph on the right, we have x goes from negative infinity and then all the way to b. So the graph on the left, I am looking for the area under the curve of f of x. X goes from a all the way to infinity. The graph on the right, I am also looking for the area under the graph of f of x such that x goes from negative infinity all the way to b. So in these two cases, when the area extends all the way to the left or all the way to the right, is the area equals to infinity or the area is just equals to a number? So if you never studied improper integral in the past, your answer will be, well, if you extend the area all the way to the right, like the example you have on the first graph, the area is just equals to infinity, right? Because you are making the area so big. All right, so that is not always true. What about thinking about the horizontal asymptote? Let's say the horizontal asymptote is the x-axis. So the x-axis is the horizontal asymptote. As x approaches to positive infinity, what happened on the first graph? X-axis is a horizontal asymptote. As x goes all the way to positive infinity, y goes to 0, right? So that means the distance between the curve and the horizontal asymptote is so close such that the area between them is very, very tiny, right? So if the area is so tiny, when you add all the areas up, the area is just equals to a number. So that number is determined by the area around x equals to a, because if you look all the way to the right, you don't really care about those tiny area because that is not going to affect the sum too much. Okay, let's take a look at the integral. So the first integral, I have x goes from a to positive infinity, f of x dx. So for the improper integral, the first type, you will see an infinity on the upper limit and then a negative infinity on the lower limit. And then when you set up the integral, you have to start with a limit. The limit is not optional. So you have limit as t goes to infinity, and then you have integral from a to t. So what you did is you replace the infinity by t, and then f of x dx, and then the integral on the right, you have from negative infinity to b, f of x dx. So you set up a limit and then replace the negative infinity by t. So there are four vocabularies that we will be using when we do improper integral. The first one is finite area. Finite area means when the area is equals to a number like 1/2, -6, pi, 15, 20, 1 million, -200, so on and so forth. That means the limit exists. So you integrate first, and then you plug in the upper limit and lower limit using the fundamental theorem of calculus to subtract them, and then you you evaluate the limit exists. So the limit equals to a number, either positive, negative, or 0. In that case, we say the area is finite and the integral is convergent. So finite means the area equals to a number and therefore the integral is convergent. And then for infinite area, that means the area cannot be determined or equals to infinity. So either extremely big or we cannot determine that at all. So that means the limit doesn't exist and therefore the integral is divergent. So for convergent, I have an example for you. For divergent, I also have an example for you. So let's take a look at the next page. So the next page, I have two graphs. I have f of x equals to 1 over x squared on the left, and then f of x equals to 1 over x on the right. My question is, as x approaches to infinity, is the area finite or infinite? All right, so let's take a look. The first integral is we have integral from 1 to positive infinity. This is called an improper integral because we have infinity in the upper limit. And then we have 1 over x squared dx. So this is an improper integral. The first step is you have to set up the limit. So you have to do limit as t approaches to infinity from 1 to t, and then the 1 over x squared is just x to the -2 dx. So first thing is you replace the infinity with t, set up the limit, and then the second step is you integrate. So limit as t approaches to infinity. By the way, you always start an equal with an equal, and you have to write the limit until you evaluate the limit. All right, so what's the how do you integrate? So we have to use simple power rule. Negative 2 plus 1 is negative 1. So x raised to the negative 1. The reciprocal of that is negative 1, such that x goes from 1 to t, and then you plug in the t, plug in the 1, so you have limit as t approaches to infinity, plug in the t, you have negative 1 over t minus negative 1 over 1, right? And then you plug in the infinity, negative 1 over infinity plus 1. So 1 divided by a huge value. On your calculator, you can try that right now. 1 divided by 9 million. 1 divided by 66 million. The quotient is very close to 0. So you have 0 plus 1, then you get a 1. So the area is equals to 1. 1 is a number, so we say the area is finite. And then therefore, the integral is convergent. So that is the first case. And then in the second case, we have integral, and then the area goes from 1 to infinity of 1 over x dx. So first step is you set up the limit, and then we place the infinity by t. T approaches to infinity, 1 to t, and then 1 over x dx, and then the second step is you integrate. So the integral of 1 over x, you do not use simple power rule. This is equals to ln, absolute value of x. The absolute value is not optional because you have to make sure that x is positive, because ln of negative is undefined. Next, you plug in the t, plug in the 1, so you have limit as t approaches to infinity. You have ln absolute value of t minus ln1, so ln1 is just equals to 0. I've just drawn an arrow and say that goes to 0. And then I have limit as t approaches to, oh, actually we don't need the limit anymore, right? We can just plug in the t. So we have limit infinity, so we have ln, not limit, ln infinity, which is equals to infinity. And then for this infinity, let's take a look at the graph of ln. So the graph of ln has one x intercept. So y-axis, x-axis, the intercept locates at 1, 0. X is equals to 1, y is equals to 0. And the graph of ln is an increasing function. And then what happens as x approaches to 0 from the left? So from the right. So we have a vertical asymptote at x equals to 0. So that means as x approaches to 0 from the left, y goes all the way down to negative infinity. And then what about the other side? The other side is as x approaches to infinity, we have y approaches to infinity. So that's why ln infinity is equals to infinity. So therefore, we say that the area is infinite. So we have infinite area. And therefore, the integral is divergent. Okay, let's go back to the graph. All right, so the one on the left is finite, the one on the right is infinite. They look almost the same, right? So for 1 over x squared, as x past 1, so let's say x equals to 10, we have 1 divided by 100 compared to f1 over x. So this when x is equals to 10. Let me use another color. So as x equals to 10, so this one is 1 divided by 10 squared, which is 100, right? So this one x equals to 10, we have 1 over 10. So that means the y value on the left is way smaller than the y value on the right. So what does that mean? That means as x approaches to infinity, the distance between the curve and the horizontal asymptote is so small. The distance is so small such that the area between them is so small. So therefore, the area equals to 1 is all determined by the area around x equals to 1. So as x goes to all the way to infinity, we don't really care about anymore because those areas, they are so tiny. When you add all the areas up, that is really just nothing. So the area is determined by x equals to 1, 2, 3, 4, 5, right? By this region right here. And then what about the graph on the right? The graph on the right, there is a bigger distance between the x-axis and the curve, so such that when you add up those area, they matters, right? So when you add up those area, well, they are not tiny at all, so they are not 0 at all. So when you add all the areas up, the sum is equals to infinity. So therefore, we have an infinite area and the integral is divergent. So this is the basic of the first type of improper integral, where there is an infinite interval. Either the upper limit is equals to positive infinity or the lower limit is equals to negative infinity. And then in the next couple video, I will show you more example regarding the first type of improper integral. All right, so if you think my instruction is clear and helpful, give me a like, share the video for me, subscribe to my channel. I will see you all in the next one. Signing off for now.